In a triangle, there are 3 angles and 3 sides. If we add the angles together, the sum of the angle measures needs to be 180 degrees. Looking at the model, angle X plus angle Y plus angle Z must equal 180 degrees. A triangle is formed by 3 line segments. A line segment is just part of a line, has 2 endpoints. These 3 segments will intersect at a vertex. Vertex is the corner of the triangle. The vertex forms the angles, and they are said to be interior angles because they are on the inside of the 3 line segments. The sides are labeled by the 2 endpoints. We would have side XY, XZ, and YZ. The vertices, or the corners, are X, Y, and Z, and then the angle measures would be angle X, angle Y, and angle Z. If you look right here, you see that little M in front of the angle symbol. That is read the measure of angle X. In the last example, we had the interior angles, and now we're going to talk about an exterior angle. An exterior angle is formed by extending one of the sides of the triangle. Angle 4 is an exterior angle because it is on the outside of the shape. An exterior angle will be supplementary to its adjacent interior angle. Remember, adjacent means next to, and they share a side. For each interior angle, there can only be one exterior angle. Angle 2, the exterior angle is angle 6. Angle 3 is the interior angle, and the exterior to 3 is angle 5. Remember, supplementary means the sum is equal to 180 degrees. So each interior angle added with its exterior angle needs to equal 180 degrees. We can classify triangles in 2 different ways. We can classify them by the angles, and to do that we look at the angle measures, and we can classify them by the sides. We look at the side length to classify the triangle by side. An acute triangle, every single angle inside the triangle needs to be less than 90 degrees. In an obtuse triangle, one of the 3 angles needs to be obtuse. You cannot have 2 angles that are obtuse, or we would be over our limit of 180 degrees. With a right triangle, it's very similar to an obtuse triangle, except we have 1 right angle. Again, we can't have 2 right angles, or we would be over our 180 degree limit. By sides, a scalene triangle, there are no congruent sides. None of them can be the same. In an isosceles triangle, there needs to be at least 2 sides congruent. And an equilateral triangle is actually a special isosceles triangle where all 3 sides have the exact same measure. We can tell that sides have the same measure when they have the same tick markings. So if all 3 sides have the same tick mark, then they are congruent and we have an equilateral triangle. The triangle inequality theorem states that any 2 sides of a triangle, when you add them together, must be greater than the 3rd side. Therefore, if we look at this example, side AB, if I add it with side BC, that sum must be greater than the length of AC. And then pick 2 different sides. BC plus AC must be greater than AB. That has to work for all 3 pairs. The measures of the angles of triangle ABC are in the ratio 1 to 3 to 8. What are the measures of the angles? There isn't a picture drawn, but if that's helpful for you to visualize the problem, by all means, draw out a triangle. These are a lot easier than anticipated. All we do is take the number in each of the ratios and we put an x with it. So x1 becomes 1x. They just didn't write the 1 in front. 3 would become 3x and 8 would become 8x. We know that all angles in a triangle, when you add them together, will equal 180. We take that x plus 3x plus 8x from the ratio and make it equal to 180. Combine your like terms and you get 12x equal to 180. Divide each side by 12 to get x alone, and we find that x is equal to 15. Now, that doesn't give us the measures of the angles, that gave us x. What we need to do now is substitute x, 15 in for x. X is equal to 15. 3x would be 3 times 15, which is 45, and 8x would become 8 times 15, which is 120. Now we have the measures of the angles. The angle measures are 15 degrees, 45 degrees, and 120 degrees. Find the measure of angle 2 formed by the legs of the director's chair when the measure of angle 5 is 168 degrees. We look down at the triangle in pink that they drew for us, and we see that 2 is an interior angle and 5 is the exterior angle. 2 and 5 are supplementary because one is the interior and the other is the exterior, and they are adjacent. Supplementary means they add up to 180 degrees. So we need to just say the measure of angle 5 plus the measure of angle 2 is equal to 180. We know that 5 is 168 degrees. We subtract that from 180 and we find that x is equal to 12. So the measure of angle 2 is equal to 12 degrees. Determine whether the measures 6.5, 6.5, and 14.5 can be lengths of the side of a triangle. We need to use the triangle inequality theorem, and we need to determine if two sides are greater than the third side. If we start with 6.5 plus 6.5, we need to determine, is it greater than 14.5? And we find that 13 is not greater than 14.5. Therefore, 6.5, 6.5, and 14.5 cannot be lengths of the sides of a triangle. Determine whether the measures 6.8, 7.2, and 5.1 can be lengths of the sides of a triangle. Very similar to our last example, we need to test all three sets. And if I take 6.8 plus 7.2, I get 14, and that is greater than 5.1. Next set of sides, I have 6.8 plus 5.1 is 11.9, which is greater than the third side, 7.2. And finally, 5.1 plus 7.2 is 12.3, which is greater than the third side, 6.8. Since all of these work, it is a triangle. In triangle PQR, PQ equals 7.2 and QR is equal to 5.2. Which measure cannot be PR? They gave us 4 answer choices, 7, 9, 11, and 13. We need to look at each individual set of sides. First of all, let's look at PR. We want PR to equal N. So PQ is 7.2, QR is 5.2, and that needs to be greater than the third side, PR, which we're calling N. So 12.4 needs to be greater than N. The next set of sides is PQ plus PR is greater than QR. I'm just going and taking the 3 sides from the triangle. PQ is 7.2. We said PR is N. So when I add those two together, it needs to be greater than 5.2. When I subtract 7.2 from each side, I get that n needs to be greater than -2. And our last set, we have PR plus QR is greater than PQ. N plus 5.2 has to be greater than 7.2. If I subtract 5.2 from each side, I get n is greater than 2. Because n has to be greater than 2, we can eliminate the n is greater than -2. That overrules the negative. N needs to be greater than 2, but less than 12.4. Therefore, the only answer that does not fit into that parameter is D. D, 13, cannot be the measure of PR.